Hello, everyone. Thank you for joining us again. This time for another Tech Visionary interviews, and this time we have or someone from our neighborhood joining us, Kate. Hey, Kate, how are you doing?
Hi there.
Thank you for joining us this time. Really appreciate
Oh, it's
the time you provided for this quick chat. Um, so the topic today is like the future of data and insight analytics. But before we jump into the topic, can you introduce yourself a little bit? Tell us what do you do and how did you get into this like data and analytics space?
okay. So I'm the Chief Data and Insights Officer at the University of New South Wales in Sydney, Australia, and I've been in this role for 6 years. And before that, I had a varied IT career and have several stints in data warehousing earlier in my career. So with the emerging digital transformation that was happening, it suddenly became apparent to me that data underpins everything. And data is suddenly going to be a lot more important. So data is a good place to be. So that's how I ended up in this role.
That's great. Thank you for mentioning that. So it's quite interesting journey that like long time ago we had a lot of like operational systems. Everyone was looking to build their own operational system to gather data. But nowadays we have like a lot of data. We are building analytics on top of it. What do you see? This is what this is going towards to? What is like the next step you think?
Well, we've spent years trying to build data warehouses that aggregate all of the data. And now we're seeing emerging technologies that allow us to leave the data where it is and go and rifle through it almost and then bring back the interesting bits to then do machine learning on. So we're seeing a sort of a step change in the data warehousing world into more of a machine learning world.
How do you see these separation like a lot of companies their question is that like in order to get machine learning and AI working, do we need a data warehouse? Like, is that prerequisite for this, or people can just like jump into that step?
I think they both have a place, and if you wanted to deliver reporting of how many X's of Y's in system Z across multiple systems, you still need a data warehouse to reliably deliver that at this stage. But increasingly, we're wanting insights that are better suited to sort of Internet of Things, IoT kinds of technologies, and more suited to machine learning, especially when we're looking across multiple systems and increasingly external systems, so that we're wanting to go out and query not just our own systems, but the transport systems, things that are outside our own organisations, and it's an API driven world now, so we can go out and query the APIs and then bring the data back. And you probably want somewhere to store it. So you're probably looking at a data lake or two as well.
Correct. And you mentioned something really important, being like in IoT, let's say, scenario or things like that, being real time or have like the minimum time to make a decision or make a, let's say, recommendation based on something is really important. How do you see the current technologies are coping with that? Do we have like good technologies that covering this kind of real time analysis?
No, we don't. So if you look at, like, my favorite one is Netflix, who really don't understand me, even though they got all of the data on the things I only watch for 30 seconds. And then they keep recommending the things I watch for 30 seconds. I obviously hate the things I watch for 30 seconds and never go back to. So there's an organisation that has all of this amazing data at its fingertips, but can't be bothered recommending anything personally for me. Whereas Amazon have nailed it, because every time I go to Amazon, they go, people who bought this, this, and this as well. Would you like to buy all of these for a special discounted price? And I go, oh, sure. And I always buy 5 books instead of 1 book, because they understand me through the data. So the companies that understand you through the data will be able to drive sales, will be able to drive marginal profit much higher than organisations like Netflix. It's interesting though that Netflix don't have a capacity model, so they the more you consume, they get the same price. So they have no interest in you consuming more. So they haven't really thought through their costing model yet.
Right.
They
Yeah.
probably will.
Yeah, that's right. Yeah, yeah, and I believe like the pattern recognition algorithms that have been applied in these two are totally different. Maybe in Netflix they don't really have anything on it; they just recommend something that you have watched before. On the other side, the Amazon have some pattern recognition checking, like based on other analysis, which brings us to like the world of predictive analytics, prescriptive analytics. Do we have really some, let's say, ways to incorporate these in real world scenarios, like even for like not for a company like Amazon, which is quite big, but for like small businesses, medium scale businesses, or some even enterprises, but not at that level of having like tons of developers, still with a group of analysts, they can achieve something similar.
Yeah, and both Microsoft and Amazon have a pretty good stack for that. You know, we've worked in both platforms, but for our we decided to go with Microsoft because our university bought an A5 license, which is basically an all-you-can-eat license. And even with a very small team, you can actually build some really clever stuff. And one of the reasons is that I went with Azure is because everything is available to you in that stack. So you get IoT out of the box for the cost of usage. So you get a lot of capability on that platform. It's a very similar story with AWS too. So, you know, and you can even Google have a story there, but I still wouldn't run production workloads in Google myself anyway.
Right. That's a good point in terms of like the actual like the way that people that companies should start. Let's say it's a business that wants to start on machine learning. What they need a team of like data scientists, people who are like super advanced in R and Python, or like a different type of skill can be gathered together to build like that expertise.
Well, the one tip I will give people is that you need more data engineers than you need data scientists. So typically, I find that one data scientist is plenty, but you need a handful of data engineers, especially while you're acquiring the data. So if you've got a known data set that needs to be acquired, it can be quite labour intensive. And if you're wanting to acquire new data sets and bring them into your world, then you'll need data engineers. So I've got a kind of a ratio in my head now of like 5 data engineers to 1 data scientist.
That is a really important point because a lot of people think that like a data scientist can do many of those things as well. The fact is that like getting data from different sources, sometimes cleaning it up, preparing it in the right shape to be analyzed further by a data scientist, those are not normally data scientist tasks. So exactly what you mentioned, that we need more data engineers. How would you consider like the whole governance around something like this, that we have like a set of, let's say, data engineers, a data scientist or two, they are building like a machine learning piece of work, how this would be controlled, let's say, across all other ways, like other IT departments and things like that working with this?
Well, I recommend that everybody needs to automate their pipelines. So they need to start to use a code management tool. So we used to use an Atlassian tool, and now we use Azure DevOps. And, you know, you need to establish your DevOps practice, and you need to automate, because I've only got a tiny team. We have to automate everything that we do, because otherwise we can't do everything. So you've got to automate your pipelines, you've got to automate your data acquisition and stuff, and we've got it so that you cannot do anything unless you commit. And we're using continuous integration, continuous deployment. So we're using all of those disciplines of DevOps in the data context, and increasingly as we move into machine learning, we're using the same disciplines.
Great. One other interesting, like not interesting, like more, let's say, common questions we get from people is that how much it would cost, not in terms of like licenses and things like that, mainly in terms of like when we talk about you need to use machine learning with a client, they say, well, this probably requires like a team of 10 people working like 3 years consecutively to achieve a result. What is your experience? Like how long normally it takes to achieve a result? It's different, obviously, case by case, but some advice on this side.
So we've done proofs of concept in 4 weeks with one person.
Fantastic.
So, a lot of subject matter experts to give them input, but one person working on it. And that's plenty to get a functional proof of concept that can work out whether or not it's going to be a viable solution for you.
Right. That's great. And what about, let's say, the reliability of business on this? That's another question we get that, well, I got this result from machine learning. It tells me that I should do this, or we should suggest these to our customers. How we can rely on, are these suggestions or things like that correct or not?
Well, look, machine learning is just mathematics, and it's basically statistics. So you can test for that. And at the end of the day, I think a human being can make a decision. You don't have to action the recommendations, but the way you should be approaching machine learning is to test a hypothesis. We have a hypothesis that this is the case, and then you test to see if the data supports it. So that's a really good approach, and I recommend to do a proof of concept for anything that you're planning. To see if it works. So one way that we're doing it is we've got one proof of concept that we're about to run at the moment, and we've got a hypothesis, and we're going to run it historically. So we've got a set of known instances historically of something that we know happened, and we've got a hypothesis about how we can test for that in the data. So we're going to run that against the historical data and see if we find all of our known instances. I actually suspect that we're going to find more than the known instances because we had human beings doing it. We had 2 people doing that job before finding those instances. And I suspect when we query the data, we'll find a lot more instances. And that will help us validate our model so that we can then start to use it predictively.
Correct. Great. Thank you. Thank you for mentioning all of these. Before we wrap up, is there anything else that you would like to explain which I haven't asked about?
I think really the important thing is that working with data is a collaboration. So it's the technical platform people working with the analytics people, working with the business subject matter experts. And if you're doing anything without talking to your business subject matter experts, you're probably wrong. So I recommend getting all of those people together. And, nowadays it's mostly on Teams or Zoom or something. But just having those conversations before you build anything so that you can make sure that it's in alignment with the business rather than just going off and doing a thing on your own. So that's my advice.
Great. Thank you. Yep, business requirement is definitely an important part of this. Fantastic. Thank you for your time again. How our, let's say, audience can get in touch with you? What is the best way?
Probably the best way is on Twitter at Carruthers.
Okay. Fantastic. Thank you again. Thank you for your time. Thank you everyone for watching us. Until next time, stay safe. Bye.
Bye.